Hey students, so we are now into the second lecture of the electric vehicle technologies, where in the previous one we have discussed about what are the pros and the cons about the electric vehicle technologies. Now, in the second one, we just wanted to see how India can drive this EV program innovatively and differently from the rest of the world, and how we can scale it. So first we need to understand the uniqueness of Indian vehicle statistics. And then in our particular stats, the battery cost, the cost of battery, it dominates the overall cost of EV, and how the India can deal with it. So that we are going to see in this particular lecture. So first we need to see the uniqueness of India's vehicle. So India's vehicle, or the count of India's vehicle, is majorly dominated by the two-wheelers. So here are the few statistics, right from 2013-14 to 2018-19. So here we can see the grand total in 2013-14, there were total 18.42 million vehicles were sold, whereas by after the 6 years, that is in 2018-19, the count of grand total of the vehicle, it is 26.27 millions. In these 26.27 million vehicles, the major share is of two-wheelers, that is 21.18 million two-wheelers were sold in this year. And similarly, we can see the share of passenger vehicles such as buses, and then commercial vehicles, which includes the cargo movers, and then the three-wheelers. Three-wheelers are majorly, it is the auto rickshaw and kind of thing. So here we see that the three-wheelers have become the main last mile public transport for 75% of the Indians. So 75% of the Indians, they are traveling daily through the three-wheelers. The cars, 14% of the total vehicle, it is cars, and the premium cars, which are costing more than 1 million, that is 10 lakh, is about 15% of the overall total cars. So 14% is the total share of the cars out of these, and out of that 15% is of premium vehicles, premium cars. Now, if I just see the percentage of cars that are being sold in the different years, so below 5 lakh, the car, those were sold, like percentage was 27.43. Then from 5 lakh to 10 lakh, the 56.48%. And then from 10 to 15 lakh, it is the 14.65%. And above 15 lakh, it is 1.43% of the total car, which is being sold in the respective years. So if I see, or if I present this data in terms of percentage, then here we can see the domination of two-wheelers in the Indian vehicle market. So in the Indian vehicle market, it is clear that the 79% of the domination is of two-wheelers. Then the 4% is of small good vehicles, and the 12% is the economy cars. So economy cars, here we are assuming below 1 million, that is 10 lakh rupees. And this combined, that becomes the 95% share of the total vehicle market in India. And then the premium cars share is 2%, and the buses and large good vehicles, that includes the 3% of the total vehicle segment. So here we can see the 95% of the vehicles owned in India, they are small, as well as these are in the category of affordable vehicles. So affordable vehicles means the people used to see their affordability first in these vehicles, since the India is developing country, and here the income is the large income group people are not very large, not very big, and therefore the majority of the Indians, they are preferring the vehicles which are small as well as which are in the affordable range. And that is the whole 95% of the total vehicle counts. Now, what can be the strategy of the India? So India's strategy is to convert the two-wheeler, three-wheeler and small four-wheelers. So here in the previous slide, we have seen that two-wheelers, this is three-wheelers, and this is the small four-wheelers, that is the car which are having the cost less than 10 lakh rupees. So that becomes the 95% of the Indian vehicle. Then buses and trucks, which are big ones, and these are 3%. Now, here the 98% is looking for the affordability. So, India can get the leadership in designing and developing these affordable vehicles because India has its own market open for these affordable vehicles. So if we just wanted to sell these vehicles in our own country, then we are having a big market within, and therefore the companies which are promoting or which are investing in the two-wheelers, electric vehicles, three-wheelers, and the small four-wheelers, and then the cargo movers, they can have a potential market within India where they can sell their products very easily. So lot of startups, lot of companies, they are now switching towards the electric vehicle segment. And correspondingly, there are jobs available in the electric vehicle. Now, for the premium four-wheelers, so premium four-wheelers are normally not built in India, normally. So that becomes a very small percentage, that is the 2% of the Indian vehicles. 98% is again directing towards the affordability. And for 2% of the vehicle, we can just be similar to the rest of world. That means we can encourage the multinational companies to manufacture and they can sell it in India. This will help us in building a stronger ecosystem for components and subsystems. Now, here I would like to emphasize one point. So in EV, there are two types of industries available. One is the industry which is working in the manufacturing of components. That is like motor, controller, battery, and powertrain mechanism, other all the parts which are required in an EV. So that is one kind of industry. Second is the one which assembles all these components into the electric vehicle. It may be two-wheeler, it may be three-wheeler or four-wheeler, depending upon what kind of industry it is. And then after assembling all these components in the form of electric vehicle, it can be then this vehicle needs to be tested for the various safety standards, and then it can be sold to the market. So this is the strategy of India, that India is continuously promoting the manufacturer to build the indigenous components within the country, and then there are companies which are assembling these vehicles inside, and then we are having a big market for it. Now, since we are talking about the affordability, because the 95% is the segment which is less than 10 lakh rupees. And then 3% it is again the cargo movers, where again the affordability is a big concern. So 98, for addressing that 98% of the market, we need to see the affordability. So here EV cost in India, energy per kilometer. So in the cost of electric vehicle, the battery cost is less than equivalent electric internal combustion engine vehicle. So in the IC engine based vehicle, the petrol tank cost is almost negligible, which is used to store the fuel. But here in electric vehicle, the battery correspondingly is a costlier option. But the cost of fuel cost of fuel, that is petrol, it is much higher than cost of charging a battery. So here the cost can be compensated. So battery is the extra cost in the electric vehicle, and it is a dominant cost, very dominant cost. Now, what can be done just to make these vehicles affordable? We need to have the higher energy efficiency. Energy efficiency is basically the conversion efficiency. That means for 1 kilometer run of the vehicle, how much watt hours are required? Similarly, like in ICE based engine vehicle, we used to see it as a mileage. So mileage is basically the kilometer per liter. So when we used to buy the vehicle, we used to ask that what is the mileage of the vehicle. So the mileage is in kilometer per liter. Similarly, in electric vehicle, we used to ask this mileage in terms of watt hour per kilometer. So how much watt hours are required per kilometer, and then lesser the watt hours required per kilometer, for the same size of battery, the range of vehicle would be more. And therefore, the continuous innovations are going on for improving the overall energy efficiency of the electric vehicle by improving the motor and controller efficiency, by having the better tires, that is to reduce the rolling resistance, tires rolling resistance, then to have a better aerodynamic design, having a lesser weight, which is relatively challenging in case of EV, where the size of battery and the cost weight of battery is more, but correspondingly the weight of IC engine is not there. So here the innovations are continuously being promoted for improving the overall efficiency of the vehicle. Now we just see that capital and the operational cost of the electric vehicle. So here in this table, you just see that first four are for the two-wheelers. So if the energy efficiency is 15 watt hours per kilometer, what is it? 15 watt hours per kilometer, which is the highest one. That means lesser watt hours are required for driving the vehicle for per kilometer. Better would be the vehicle. Better would be the vehicle. So if I am buying a battery of the cost 18,000, then the vehicle can run for 56.7 kilometers. Now, for the same size of battery, same cost of battery, if the energy efficiency has been 20 watt hours per kilometer, then this range for the same vehicle will fall down to 42.5, because here the watt hours required are more. Then if the energy efficiency further goes down and it becomes 25 watt hours per kilometers are required, then range is further reducing. It is reducing to 34.0 for a battery which is costing around 18,000 rupees. And then if the energy efficiency goes to 30 watt hours per kilometer, the range of vehicle becomes only 28.3. And similarly, as the size of battery increases, we can see the more kilometers are getting covered. But at the same time, if we are seeing the energy efficiency, like we can just see here that energy efficiency have been 15 watt hours per kilometer, and then energy efficiency have been 30 watt hour per kilometer. So it is 56.57 and it is also 56.7. The same range is being provided by improving the energy efficiency by 18,000 rupees battery, whereas in the 30 watt hours, this was same range was offered by the 33,000 rupees battery. So how this is being calculated? Just have a look. Like for 100 kilometer range, we can just see the energy efficiency has been 25 watt hours per kilometer to 15 watt hours per kilometer. So like for 100 kilometer, how the battery size would be determined? I'm just using the pen. Now, as I have already mentioned in the previous also, 100 kilometer. So for 100 kilometer, how much energy would be required? So 100 into 25 watt hours. But if we are assuming the overall efficiency 0.85, then it becomes 2.9 kilowatt hours. So this is, and if the energy efficiency has been only 15 watt hours per kilometer is required, then correspondingly the size of battery is reduced to 1.8 kilowatt hours in place of 2.9 kilowatt hours. And similarly, the cost of battery is also reduced from 43.5 thousand rupees. The cost of battery becomes 30,000. So here the affordability comes into the picture. So how the affordability of the vehicle can be improved? By having the better design, better overall design of the vehicle. That means having efficient motor, efficient power converting interface, that is power electronic interface, which is coming in terms of the controller. Then having the better mechanical components, like lesser rolling resistance, then better aerodynamic design. So just by improving the overall design of the vehicle, we can have the better energy conversion, and better energy conversion will lead to the reduced size of battery and correspondingly the reduced cost of battery. So here again, we can have this exercise. So there is a two-wheeler which is using 25 watt hour per kilometer. So now we need to see that what will be the size of battery for 80 kilometer range. So 80 kilometer is what? 80 kilometer is the range of vehicle. So range of vehicle is 80 kilometer. And then for 80 kilometer range, how much energy would be required? So energy required would be 80 into 25 watt hours per kilometer. And then we are assuming that the overall system is 0.85% efficient. So it is basically 2000 watt hours divided by 0.85. And then correspondingly, we just have the 2.4 kWh. So this is the size of battery. Size of battery. So now the cost of battery, this is the size of battery, that how this, what will be the size of battery. Now second is the cost of battery, how the cost of battery can be found out. So the cost of battery, you can see here that the cost per kilowatt hour is 18,000 per kilowatt hour to 13.5 kilowatt per kilowatt hour, depending upon the size of battery. So bigger battery would have the lesser kWh price, and smaller battery will have more kWh price. So if I am considering this 2.4, then the cost is like here it is 18,000 rupees per kilowatt hours. So correspondingly, if I am considering 18,000 rupees for 1 kWh, then for 2.4 kWh, it would be, what will be the cost? Cost would be 18K into 2.4. So it is nearly around 36 and 0.4 more. So it is 0.18, 1.8 rather. So 1.8 into 4, 3.6, 7.2. So nearly 36 plus 7.2. So it is 43.5 thousand rupees. K rupees. So the cost of battery, if I am considering 18,000 rupees for 1 kilowatt hour. So if I am going for a bigger battery, because in the smaller segment, we used to go for the small segment, small battery only. But if we go for a big vehicles, then the cost per kilowatt hour reduces and it can ultimately fall down to 13.5. But as the battery technology, it will evolve, the cost of battery per kilowatt hours, it will also reduce. So Indian market is getting prepared for the electric vehicle by having better design of the vehicle, energy efficient design of the vehicle, and by reducing the cost of battery per kilowatt hour. So the lot of innovation is going on, lot of research is going on, lot of product making is going on. Government is funding so many startups, so many businesses in this, just to have an ecosystem of electric vehicle in India itself, because inside our country we have a big market for it, and we just want this opportunity to be availed by the Indian industries, in place that someone comes from outside and then they have their electric vehicle to be sold in India. So this is how government is promoting the indigenous product making. But we need to understand that how an energy efficient vehicle can be designed, and for that matter we need to study the vehicle in detail. uh, every part has to be studied, and which we will be taking up in the further classes. But I hope you are enjoying these classes, and you will be learning through these lectures. In the first two, we have simply talked about the how the energy, volumetric energy density, then what are the various challenges, and now how we can have a better design. And then for that matter, we need to understand each and every part of the vehicle in detail. So thank you very much for giving me this patient listening. I'm just stopping here. We'll meet again in the next class. Thank you very much.